All right, Chris. So now we get to bring it all together. And in doing so, we're going to use the data that we were able to acquire through the Measure Across America pilot that we did. And so to give you a little background on Measure Across America program, is really the reason that we decided to embark on this was to advance responsible pavement marking management for both human and machine-driven vehicles, because we truly believe that lives are on the line. So starting out, let's talk about our route. Our route for Measure Across America pilot was the 1,100 miles. We went across 38 roads in 5 states, and we basically categorized our roads in 3 types. We had non-interstate and interstate. Our non-interstate, we drove those northbound, and we drove interstate southbound. Non-interstate, we divided into 2 segments. One was under 50 miles per hour and one was over 50 miles per hour. Now, the reason we chose that and to do it that way is because a lot of other studies are use those as their segmentation, and of course FHWA looks at that as well. So that's why we wanted to do that. Tell us a little bit about the features that we use to do that, Chris.
All right. Well, first off, of course, you're using the GPS to be able to collect all that information and categorize it, and then utilizing those KML files that we saw just a few moments ago.
Yeah, I guess we can't forget to thank Google for this one, right? Because this is really cool, being able to look at this map and see your route and be able to, again, back to what we were talking about earlier, that we can go right into that and zoom in and see what those attributes are that we collected. So miles measured, as I said, was about 1,100 miles. 152 of those miles were under 50 miles an hour, and 426 were over 50 mile an hour, and then 525 miles were interstate miles. And the majority of our assessment took place in Georgia, North Carolina, and South Carolina. We had some great sampling from those states. We had some small sampling out of Virginia and Florida. Florida, because we started only about 50 miles outside of the Georgia state border, and Virginia, actually, the primary reason we had so few readings in Virginia was because it started raining on us. Tell us a little bit about those features that we used.
Right, so you're able to use those file names for your headers on all of your different files when you're going from state to state, and then getting on those different roads. Then you're able to use those road conditions or your attribute buttons that are going to be able to tell you, because you did have it set for an under 50 and an over 50, and these things will all come up on your CSV file.
Yeah, something I might suggest for those guys using this, it's great when you have 3 options, just put 2 on, because if it's not 1 or 2, then it's going to be the third. In this case, we didn't have to click an interstate button. We just said if it's over 50 or under 50. If it was neither, then we knew it was interstate miles. So that was kind of cool. And of course, you're going to see throughout that the CSV file is listed on just about every one of these, because that's where we're getting this data from. Marking type. So again, this is what they call stripe type, and on the panel, and so we had single solid, single skip, double solid, right skip, left skip, and so forth. You can see that the vast majority of our markings that we measured was a single solid, and there's 2 reasons for that. One was the interstate. Again, all we measured was yellow center line, so all these numbers that you're going to see is based on yellow center line. If we captured some white, we threw out that data for this particular event that we did, just so that we wouldn't have any confusing or conflicting numbers. So the reason it's single solid was, of course, interstate, all single solid on the edge line, and then of course on the off interstate we had a lot of median or divided highways. So again, that just requires a single solid line, but you can see 55% of our readings came from those lines.
Right, so on this one, again, you're using those big buttons of the stripe type, easy to change out when you're changing from one stripe to another. And again, this is going to be one of the columns on your CSV file.
Well, now we get to valid scans and measurements. You heard me talk about this earlier, and we had 16.5 million valid scans. And basically a valid scan, well, I'll let Chris explain what a valid scan is, but we were able to average, we set the interval average at 0.05 miles. That's about 264 feet. So every 264 feet, it would take whatever scans were valid in that section, and it would average those. What was really cool is we ended up with about 15,000 valid scans per mile. You can imagine Chris being out there with a handheld trying to take measurements, 15,000 of them in a mile. A lot of requirements are usually one in the middle, one in the end, and one on the other end. So beginning, end, and middle. So you got a lot more representative numbers. I do want to mention here the importance of this type of assessment, this many numbers, because pavement markings it's all about the averages. If you take 3 measurements, you are not getting a representative number or average of retroreflectivity. The more you get, the more representative it is. In our particular case, we found we got 8.5 million on the interstate. We got 5 million on the over 50 miles per hour. And we got another 3 million, or the balance of the 16.5 there, in the under 50 miles per hour.
All right. So again, you're using that laser system that is doing 400 readings per second, but then your record averaging is what really helps you out here. Some guys might want to look at 16.5 million scans, not me. So I like that averaging. And then you have, of course, your road conditions or your attribute tabs. And then on your valid scans, as you said, Greg, a valid scan is when you set up the unit, you can set a minimum. So anything that's under that minimum, it's going to throw it out of the reading and not count it as a valid scan and make it part of your averaging.
Yeah, that's part of your, I get a lot of questions that ask, well, what happens if it's a skip line? Will it average where there's a line and where there's not a line? So if the line's 100 millicandela, will it be 50? And absolutely not. That's what you're actually setting that number for, so that it'll knock out those blanks and say, hey, there's no line here, so we're not going to put that in our averages. So yes, that was awesome. 16.5 million, just pretty impressive there, even for me as a data guy, right? Average retroreflectivity. So the average by road type was, of course, the interstate. We had 152 millicandela per meter squared per lux, probably to the discomfort of some of the top engineers out there. I'm just going to say millicandela. So as we move forward, non-interstate over 50 miles an hour was an average of 143 millicandela, and non-interstate under 50 miles per hour were 137 millicandela. Now, one thing I did like about this, one thing I didn't like about it is these are fairly low numbers. It's just I'd like to see these numbers higher. But what I was impressed with was the faster the speed, the higher the retroreflectivity in most cases. We did do a little bit more breakout, I'll show you in a moment, that concerns me about the interstate miles, but or the interstate retroreflectivity. But it was nice to see that difference. Chris?
All right, so again, using that speedy laser system to pick up all those readings and catch those millicandelas, the road condition attribute buttons, and then our record averaging came into play on this one.
All right, so we had retroreflectivity averages, but sometimes the average doesn't tell you the whole story. So what we wanted to do was create these levels, we call them retro buckets. And so what we did was we started with 0 to 50, basically, and we went all the way up to greater than 250. Now, the reason we did this, we did it in, you'll see the variance is, 50 millicandela to 25 millicandela, somewhere in there. And we chose these low numbers. We find that oftentimes markings are well over 250, but I wanted to focus on that lower end, Chris, where we could watch for those subtle changes and those subtle averages and groupings, as you'll see in a moment, of the retroreflectivity. And really, primarily, to be honest with you, was I feel that that FHWA's retroreflective, their proposed minimum retroreflectivity levels are a bit low, and I felt that if we could prove that the average roadway is actually higher than what their requirement is, then I might be able to get them to bump up that retro requirement. So anyway, let's see what happened. So on non-interstate, the numbers that really stand out to me is this 24% of non-interstate roads were at a, let's see, level 2, so we're at 100 and either 100 or less in retroreflectivity. And so 100 millicandela or less in retroreflectivity. So that's a little concerning that we ended up with such low markings. And then if you look on the high end, you can see that about 17% were over 200 millicandela. So that was nice to see, but it was concerning about the 20. It wasn't, Chris, it wasn't a surprise. It was just, unfortunately, I would have liked to have been surprised that it would have been a lot less. It wasn't a surprise, but definitely notable. But when we moved to the interstate, this was a surprise. 32% fell under that 100 millicandela, which really is a little unnerving considering the speed, 70 miles an hour that you're driving. And you need more distance for that reaction time, and so that's really concerning. We also found though that it had a higher percentage of high end, about 25% compared to that 17% of non-interstate were 250 or 200 or higher. Very interesting data that we got out of that, and of course it looks like similar features we used as well.
Right, and one of the things that's really great about this is when you look at those retro buckets that you had set up, all of those colors that you have assigned to that, those are going to come out on your KML map, and you'll be able to have a visual representation of your markings, which is great for maintenance. There's some guys that they only want to know, does it pass, does it fail? But when you're talking about maintenance, this tells you kind of where you stand and where you need to maintain first, and then set up a calendar to kind of go through your markings and get them up to where you want them to be.
Excellent. And also note here, this is where we can go into those settings in the very beginning and set up what those buckets are and what those ranges are. Right. In this case, we were able to actually do that, and then in post-acquisition, we were able to we actually are able to change those buckets. So that was kind of cool as well. So now let's talk a little bit about retroreflectivity deviation. This is identification of longitudinal inconsistent retroreflectivity. This is basically dark light, dark light, dark light, or when you have some corrugation, or mainly this occurs when there's like on a curve. The markings will deviate a little bit because of being run over more often, a construction zone, that type of thing. There was quite a bit of deviation here. We found that interstates, and what this does is it basically takes the highest reading of that batch, of that average, and the lowest reading of that average, and then it says, okay, how much did it deviate from one to the other? And we found that on interstate, not too bad, about 22% deviation, but then when we got into the over 50 and the under 50 non-interstate, you can see we averaged about 32%. It had about 32% deviation in the lines and the markings.
Right. So when you take a look at these, you're again using those maximums and minimums on your deviations, and once you set those up, that makes it the more detail you use on those, the better information you're going to get on the back end.
Yeah, something else that needs to be mentioned, what this does also is it identifies if it's a new marking. It can identify very quickly if there was a bead issue, if there's a bead dispensing issue, pressure changes throughout the install, some kind of surging, that kind of stuff. So very good, especially for the newer markings. Now let's talk about marking width. This is the nighttime width. We talked a little bit about that earlier. We had an average of on interstate about 4.79 inches. On under 50, we actually had a wider line than over 50. Now, as I said earlier, we had set that up to be a 6-inch. We had a little 6-inch, 4-inch toggle that we could go back and forth, trying to decide determine which size line it was. But it was often very difficult because a lot of these lines, Chris, were worn, and lines wear, again, I talked about it earlier, wear from the outside in. And so we couldn't tell if it had started out at 6 or started out at 4 because it was only 3. So we didn't know if it had worn 50% or just worn 25 or 30%. So that was a little difficult to monitor for us because we didn't know, go in knowing how wide that line was supposed to be. But these are the averages that we got. Of course, we're big proponents of 6-inch lines for a number of reasons.
Right, and one of the things that I think really comes into play with this is the fact that you've had a number of states recently that have changed the width of their markings, and they've gone wider for a reason. And so if you've gone to a wider line, but yet your nighttime width is not there, then you've kind of defeated what you started out trying to achieve.
Yeah, I know we mentioned it earlier, but it's worth mentioning again, is that this is what the nighttime width looked like. This line could have very easily looked like a 6-inch line or a 4-inch line, in the daylight. But when we actually put a retroreflectometer on it, at night, it was only showing up to these widths. And we did find that. We found that in a lot of center line, brand new center line, measuring at 3.5, 4 inches, when it was a 6-inch line. And it was mainly because in that case, it was what we saw, it was either bead distribution, or it could have been that inconsistent paint thickness across the line, being not allowing the beads to adhere properly across the line and then wearing off rather quickly. So very important. Nighttime width is something that we forget about the importance of that. Let's go to material types. So we found that about 850 of our miles were in thermo, 290 miles were paint, and 16 miles of tape. I'll start with the tape. The tape was this again was one of our one of our buttons, our road condition buttons, and we would say, okay, so we found the 16 miles was mostly going across bridges. They're using a lot of tape on bridges in the southeast, so I'd click on it. I will say that the thermal and paint, the data may not be exactly accurate, because it was a lot of times, Chris, it was hard to tell. I thought I could do it 3 decades in this industry, and I could just drive down the road 60 miles an hour and tell you if it was paint or thermo. Well, normally I can, but the problem was that in the southeast, we put paint over thermo. If the thermal starts to wear and lose its retroreflectivity, then we put a paint on top of it. And you can see that, you can see the edges where it kind of overlap that thermal. But what we also do is, before, we use paint as a temporary material until we do the thermo. So a lot of times it was hard to tell which one was on top, the thermo or the paint. But we did our best. And so just that, out of all these numbers, that's probably the one that I would consider the most sketchy.
Right, so what you're using on the LLG7, of course, on laser system, you're using your GPS odometer that tracks when you're hitting these different paint, thermo, tape, etc., and your road condition buttons. And I can tell you, I did a demo about a month ago, and we hit 3 different types of markings within just a few minutes. So it was great to be able to move back and forth through those on the road conditions and catalog that.
Yeah, especially, because they definitely have some different retroreflectivity qualities. Going from paint to thermo to tape, you're going to see a difference in those numbers, and it's nice to see why they jumped or why they dropped and so forth. Not that I prefer one of the videos we do in Measure Across America is what marking material is preferred, and I'll just leave it at that. Go check what this one man's opinion is. All right, let's get to nighttime color. So again, biggest surprise by far. So looking at road type, we found that we had nighttime color failure. That means that the yellow fell out of the color box. And nighttime failure on interstate was 15%. And then on the non-interstate roadways, about 22.5% were failed yellow color. Now, we broke that out by state. because we were able to with the segmentation that we were doing with our data. And we found that the primary, the one that had the most problem with yellow was South Carolina, which was really interesting because they did not have the lowest average retroreflectivity. And what we were finding was the failures were on the newer lines. The retroreflectivity was beautiful. In the 300s and so forth on a yellow line, which is a really good number. But the problem was it was they were blowing out and going into the white box instead of the yellow. So it was very concerning to look at these lines on these state roads and finding that or these off interstate roads, and finding that the center line was looking white rather than yellow.
Right. So on this, we're using 3 lasers. We've added our 2 color lasers, and we're using our road conditions tabs, and also our file name to show where we are, which state we're in, what road we're using. And Greg, I got to tell you, in this last year, I've had a number of state DOT officials talk about the importance of yellow at night, and really kind of comparing it by, if yellow is important to us in the daytime, why not at night?
Yeah, absolutely. Because, well, let's make this comment. Yellow markings are by far the most common and best deterrent for wrong-way driving. Yellow lines divide traffic going opposite direction. If you cross that yellow line, you're going into incoming traffic. And most wrong-way accidents happen between 10 p.m. and 4 a.m. And so that's that in those night hours, those hours of darkness. So absolutely, it's even more critical because you lose all those other visual cues around you, that you recognize that on the left-hand side you see the back of signs. Okay, well that tells you, if you're looking at the left-hand side and you see back of signs, you're not sure if that line's white or yellow. Well, then you kind of figure out that that's probably a yellow line. That's in the daylight, but in the nighttime you don't have those type of cues. So very critical that you have that color reflect at night. And there's many reasons why yellow doesn't reflect when it doesn't reflect, and it reflects that whiter color. And that's in another presentation or two. So welcome to look those over. All right, operation time. What's really cool about the LLG7 for us, we were able to operate the machine both day and night. Most of our assessment, 78%, was done in the daytime, and about 22% were after nightfall.
Again, this is something that's really great about the LLG7, and really this is the only MRU in the market that it's not restricted by any time of day or night. So if you can only measure at night hours, you lose a lot of days and a lot of time. Let's say that it's raining on the night that you want to go out and measure. Well, you got to wait for that to go to the next night. So the other thing that's cool is that because it's a laser-based system, you can drive into a direct sunrise or sunset, and it doesn't bother that laser. It's going to keep measuring the line just the same way.
Yeah, that's something that's really come to a head lately, is this sun glare from sunrise, sunset, low angle, light coming at you. And so it's nice that you don't have to, when you have those conditions, you don't have to pull over and wait for that glare to be removed, that you can go ahead and continue your assessment. It's kind of like with a lot of these features, day, night operation and everything else. It was just great for us when we were out there that we were able to really just go. The only thing that held us up was dew and rain. And it's just mainly because not just that the instrument could measure it, but the problem or concern is that what you're measuring is not what you're supposed to be measuring. You're supposed to be measuring a dry line. So really cool that we were able to do this at any time of the day. All right, let's get to questions and answers. We, of course, this is a recording, a re-recording of a live presentation. So we'll just tell you a few of the questions that were asked and what our answers were. Chris, I think one of the questions was regarding having the vision system and the color system. So the LLG7 comes in three forms. It's the LLG7 Standard, LLG7 Vision, and LLG7 Color. Can you get the vision and the color in the same unit?
Greg, at this time, we can get either the color or the vision, but not together, and that's because we've just run out of space inside that cabinet. So when you add color, you're adding 2 more lasers, and that brings you to a total of 3. And so there's not going to be room to add that infrared. So right now it's a choice either between infrared or color.
Okay, and another question that we had was, can we measure in the rain? That was an interesting question.
Right, and you know, there's really 2 answers to that one. One is yes, you can. If you want wet readings, there are some configurations you can set up that's going to keep road spray from getting on the LLG7. But normally the spec that we're trying to meet is not for wet readings. So you wouldn't want to read in the rain. And in the normal position, you will get tire spray. And so it's going to occlude that screen. And really, number one, your retro on your beads is going to be different and off. And as well, you're going to get that screen clouded up pretty quickly.
Yeah, and you know, there was another question that was early on, and I know we've addressed it. I addressed it a couple times, and you as well, is about, and the tandem takes care of that, but it was, can you measure more than one line at a time? And you know, the answer to that was that, well, first of all, center line, double, single, it doesn't matter. We'll call that a marking set. You can measure both sides using the LLG7 tandem setup at the same time. There was a question about measuring the detail, the messages and so forth, the lateral lines and so forth. And really, there are no requirements out there for that at this time on these mobile assessments that you would measure an arrow, or you're going to measure a merge message or a crosswalk or anything. That's usually during construction. Sometimes you'll have to give them initial readings, and those are generally done by a handheld. But really, for a mobile environment, that really isn't something that is necessary at this time. But the tandem setup, definitely you can measure more than one line at a time. Well, I think that's good enough for us at this point, and we just really appreciate you guys listening in. And we do have a survey, and we'd love for you to come and join us at pppcatalog.com. And we definitely would like to know how we did, any type of consultation that you need for your individual needs and concerns. And also, of course, if you want to quote, we'd be glad to do that on any of the retroreflectivity equipment or the other innovative solutions that we have. So thank you again for joining us. Chris, thanks for sharing the mic with me. It's a lot better when we have a couple of us on this and get it from different perspectives. But we hope that you enjoyed out there listening to not only the features, but how they function in the field, and what difference it made as an operator and as someone doing an assessment. So, Chris, thank you very much, and you guys have a blessed day.